Good afternoon, this is Sean McKay and this is my final presentation for my Entmlgy 5600 class. The Tiny Menace, an article I found in the Landscape Architecture magazine, the magazine of American Society of Landscape Architects. This article was written on March 13th, 2018 by Ann Raver. It talks about the invasive shot-hole borer and its effects it's having on Southern California. The invasive shot-hole borer has had some taxonomical confusion in its past. Wallacia fornicatus was described in 1868 by Eickhoff as Xyloborus fornicatus from material collected in Sri Lanka. But that information was lost after World War II. In 1917, it was commonly referred to as the T-shot hole borer. In this presentation, I'll talk about the polyphagous shot hole borer and the Kuroshio shot hole borer, which produce similar crop damage, but have a slight DNA differences. The polyphagous shot hole borer was first collected by the California Department of Food and Agriculture using funnel traps in LA in 2003. It is a type of ambrosia beetle, and at that time the insect didn't appear to cause any significant damage to the economic crop plant. But in 2010, box elder and California sycamore street trees began to die. The Kuroshio shot hole borer was concentrated on California's coast and in the San Diego County. It killed 180,000 willow trees in the Tijuana River Valley, and it is suspected that these shot hole borers were introduced to California from shipping and packing materials from Vietnam. The Kuroshio shot hole borer and the polyphagous shot hole borer collectively are referred to as the invasive shot hole borers. Their plant palette consists of over 362 plant species, in which they can actually reproduce in 62 of the woody plant species. 23 million street trees are vulnerable to these shot hole borers, and that equals 33% of Southern California's urban canopy. The estimated cost in the next 10 years for removal and replacement is an upwards up to $15.9 billion. Invasive shot hole borers bore into trees and transmit pathogenic fungi, blocking water and nutrients from flowing. These fungi would be Fusarium wallacea and Graphium species. On the slide, I've listed the trees that are most susceptible to the invasive shot hole borer, the most being the Quercus agrifolia or the live oak. The females act as vectors, boring into the tree trunks, establishing networks of tunnels in the xylem. These tunnels are inoculated with the fungi, and the invasive shot hole borers then live and reproduce inside of these tunnels using the fungi for food. Weeks pass and then females emerge and find homes in new trees. So what are we doing about this invasive pest? Studies are showing conflicting results in effectiveness of pesticides and fungicides. In 2017, a study was done, and combination pesticide treatments showed more effectiveness than single treatments. The biological fungicides Bacillus subtilis only provided short-term control, and no pesticide showed substantial control over a long period of time. Physical controls are used as a component of IPM. Examples would be material removal, burning, solarization and proper mulching, and chipping of the infested plant material. IPM practices in urban forestry and agriculture include pesticides, but they tend to be very expensive and not efficient into moderate or highly infested trees. Pesticides also can't be used near aquatic habitats, such as these riparian buffers that are being affected by these invasive pests. With future research and more investment into this problem, possible IPM solutions could be biocontrols from endophytic bacterial inoculations, introduction of natural enemies, parasitoid wasp would be an example. We must limit the expansion of species and prioritize these investments for long-term solutions. Outreach and education of the public is extremely imperative. Thank you so much for watching, and here's a list of some sources if you'd like some more information.